Okay, let's start by opening the previous library we saved. Control-O, and that was CMOS EDU3. And if you take a look, there's our layout of our inverter. Here's the schematic of our inverter with our exports in and out, only 2 exports. Here we have 4 exports. We exported VDD, in, out, and ground. Then here's our icon we made for the inverter. Alright, so if we go back over here and we do an LVS, or we do a layout views and compare schematic and layout views of the current cell, we see that there are some errors. Well, not errors, but the VDD and ground are implied in the schematic where they're actually exported in the layout. So I want to fix that. Now, most of the time I don't want to show VDD and ground here, but let's just say I do, especially if I was making a biasing circuit for an op-amp or something along those lines. Alright, so let's go, and we don't want to mess with these cells, but we want to show how we can get a clean LVS. So I'm going to left click here, then right click, and then I'm going to say duplicate cells in group, and I'm going to call this the same name, but I'm going to put connector, or CONN, on the end of this cell group. And now if you go over here, I get the same copies of the cells, and here I've got a copy of the cell. But I'm going to modify this, and just to show that it doesn't pass the LVS or the NCC, again, I have the ground and the VDD. So I'm going to modify the schematic so that it has connectors for ground and VDD. And to do that, what I'll do is I'll go back to the schematic. So we have these we can use. But I'm going to go modify this cell here by deleting that node, the power node, and deleting this node here, the ground node. Now, I can leave it, I can put off-page nodes in here like this. Let's export that node, Control-E, to VDD. Come down, right-click and drag. And let's see. And then let's export ground. So we right-click and drag. And then notice I have that port of the node highlighted, Control-E, GND. Now, before I go any further, notice that on my icon I have 2 more exports here. I'm going to go, I can select this, and what was the command to push down into a cell? Control-D. I can go there directly and it pulls up the artwork. So I'm in, now I'm editing this cell right here, which I can double click and go on into. But let's go back here. Whoops, wrong one, sorry, this one. There's our ground and all that. But let's go back in and then push by going Control-D. Let's see, edit, cell. We want to go down in the hierarchy. Control-D. Now I can move this over. I can move this over. And let's see, I had some problems rotating that before. So let's try Control-J. That doesn't work. What was it? Mirror, up, down, rotate, 180. Nothing's moving that. So what I'm going to do instead, I'm going to do like I did before. I'm just going to delete it. Delete that export. Then I'll come back and go back to my schematic. Click on the wire pin. And we'll just put it here. Right click and down. Right click. Down. Go down a little ways. Then I'll select this. See if I can get the pin. Whoops. Try Control-E. Now it's going to say, do you want to export? It's not going to work because I've selected an arc. I haven't selected a node. So must select a node, cancel. So let's go put that here and select that. Control E, VDD. Okay, I didn't need to put that pin there, but now I've got VDD and ground. And I can move that up if I want to make the connector a little better. Now I can either go back to my Explorer and click on the icon, or I can go back up in the hierarchy. Because I pushed down in the hierarchy, I can do a Control U and go back up, and there's the cell. So now I'm going to save, and then I'm going to, in this connector cell, I'm going to do an NCC. No errors found. And of course there aren't, because I've got my VDD connection here, my ground connection here. Now, let's do one other thing. So I could, let's do a quick sim here. Let's go open this, and now I've got a sim for the basic inverter without the connectors. Let's right click on that and then say duplicate cell, or create a new version of this cell. So before I do that, let's look at what we have. So here is my grouping, and this is just for simulating the inverter. I have the inverter sim schematic and the inverter sim layout. I'll right click on that cell, and I'm going to click on create new version of the cell, because I might want to be trying all kinds of things and just making new versions of the cell without, generating a new group or anything like that. So I do that. Now notice the plus sign here, and now I've got this new version, and then I've got the one that the existing version I had. So let's go ahead and save. Then let's go in here, and this is a new version of the cell. I'm going to go ahead and delete that. Why don't I make a mistake here? I'll take my inverter. Well, let's make a couple of mistakes. Let's just pull the inverter, which is this one, pull it down into this sim. And it's going to say, you really want to pull the icon down, don't you? Whoops. Did I pull the right thing down? Control Z. Well, let's pull this down here. And there's my cell. And now I'm going to line it up. Now notice, when I do if I go back in fit this contents, when I do my DRC on the schematic, oops, these nodes are not, let's see, DRC, 0 errors found. Well, something's not right. Let's go over here, right click, pull, right click, pull. Let's go up, right click. So I'm going to double click on this node, name that node VDD. Double click, no, not node, it's a arc. Keep using Spice Talk. And this is in. Then double click on this node, out. And then double click on this node, and that's GMD. Now if you look, I have from node ground to 0, I have a voltage source of V ground. On my input, I've got a voltage source of V in. So now I'm ready to generate a netlist and simulate. So we'll go sim, and let's call this CONN1. And let's go open up that directory and simulate. And there's our nice little inverter switching curve. Close this. So I've got a new version. There's my original one where the VDD and ground are implied. There's my version without there. Now just to repeat what we did, we went down here, we laid out an inverter. When we do the NCC to check to make sure the layout and the schematic match, we get that VDD and ground in the schematic are implied. If I go back over here, I get the exact same layout because I duplicated the group. But now in my schematic, I've externally put or generated these connectors or put these connectors in. So when I do my NCC, now there's no errors. Let's see. What if I want to draw the body? Let's double click on this. Oops, cancel. More. If I want to draw the body If I look at this, my body default is connected to VDD for my NMOS and to ground for my VDD for my PMOS and to ground for my NMOS. But if I want to draw the body, how do I do that? Well, I select the node, then I hit Change or C, and I go up here and I can make a 4-port transistor. Apply. I can go here and I can make a 4-port transistor again by pressing C, Apply. Now I can explicitly draw the body, and of course if it's an N-well process, all of the NMOS are sitting in the P substrate, so you've got to connect the substrate of the NMOS to ground. So this really isn't necessary, but it's good for learning. Now I might want to draw this or move it so the body of this device is at the top. So I could go nuke. Well, before we go any further, let's do a DRC and see the errors. Oh, we didn't check the wells. Let's go delete that. No, whoops, Control Z. Let's zoom in on there. Then select that. Select here. Select that. Now I can do a Control J or rotate a few times. Oh, that didn't work. So let's go up and mirror. Up, down. Oh, there we go. Pull that over. The left. Select with the left and draw with the right. And then can go up here and draw. Oops, let's go up and continue drawing. Fit. Save. DRC. One error. I bet it's a unnecessary pin. So I shift through the errors with the greater than or less than sign, just like I show there. Whoops, select the window. Greater than, it says unnecessary pin between two arcs. So I just hit delete, save, tool, DRC, no errors. Let's do an LVS before we stop, or an NCC. No errors found. So now I've got my cell with my body drawn explicitly, or my N-well drawn explicitly from the PMOS, and my source connected up here exactly like I have in my layout. So there's my body or my N-well connection for my PMOS. Here's the body or the N-well connection for my PMOS. Alright, so now let's see. Let's go back and look at a few things here. Preferences. If I go to Tools and then I go to DRC, I can turn the incremental DRC on. I can go to well check. Must have a well contact in each area. Must have a well contact. Must connect to power. Must connect to ground. Okay, so if I go back here and do, let's see what happens if I do an electrical rule check and check for ground. They are checked. Same thing here. Electrical rule check. Everything's fine. So we're good to go on our schematic versus our layout. Alright, so let's see, what else can we do? How was it we made sure that when we did the LVS it checked sizes? Go back to project or preferences. Here, preferences. And then we do our DRC. And let's see, where was that? Key bindings, display, if we want to change colors, grid, I/O, different formats, technology, design rules. If we want to change the design rules. No. Alright, so let's go back here into project settings. Let's see, technology, submicron, scale, 300 nanometers, net lists, etc. It's not there, so I must have missed it in the project settings. So icon, units, design rules, technology, tools. Pretty sure it's in the NCC. Oh, there it is. Check transistor sizes, and you can put an error if you want for relative error sizes. All right, so let's stop here And when we come back, we'll generate a ring oscillator. We'll do some basic layout and then generate a ring oscillator using the schematic and do it with the layout as well. Let's save this library as library 4. Save. And call it quits.